Welcome back, Algebra 2 students. Today we are going to move on to part 2 and finishing up the writing exponential models section of chapter 6.1. So, one of the things that I want you to remember is what an exponential model looks like. We have an exponential growth model that looks like the following: y equals a times the quantity 1 plus r to the power of t. We have an exponential decay model which looks like the following: y equals a times the quantity 1 minus r to the power of t, right? So these are what exponential models look like. And we're going to create one based on the information that's given to us, right? Based on this word problem. So let's start off by reading. In 2000, the world population was about 6.09 billion. So just from the phrase in 2000, right, it kind of gives us a starting point. It kind of gives us that we're going to start off by calculating what happened in that year. We're not starting in 2010. We're not starting in 2020, right? Which, by the way, the census is going on. Make sure to get that done. In the year 2000, is an initial amount is when we are starting. So if we are reminded which variable is dealing with the initial amounts, that is the variable a. So we can tell just based off the first sentence that our a value is going to be 6.09 billion. So go ahead and write that down. A is equal to 6.09. Now, during the next 13 years, the world population increased by about 1.18% each year. So, this straight out percentage reminds you of, if you can tell, percent increase, that R. So you can tell that the R value is going to be R equals 1.18%. Now, remember to always do this right away. When you get the percentage, you should change it already in decimal format. Now, one of the things that I said incorrectly is that wherever you have the percentage, you move 2 spaces to the left. You move a decimal 2 spaces to the left, and that's going to be your decimal. Now, that was wrong because that was a whole number. In that example, the previous one, we had a whole number, right? So we moved it 2 spaces to the left in this direction, right? Now, we start off with the whole number, or after the whole number, wherever that decimal is. You can see right here by my mouse what I'm clicking, right? So here we're going to move it 2 spaces to the left. We go 1, right? So now we go 2, and we put the decimal right here. So there's going to be a 0 in front of the 1. Now you can tell by where the decimal used to be at, which is right here, and it was moved 1 and 2 spaces to the left, right? So the very first thing it asks us to do is to write an exponential model, right? One of the ones that we just had before, which is, we know it's going to be growth, so we're going to be dealing with this model. Now, exactly what we said, the initial amount A is equal to 6.09, R is equal to 0.0118. So the exponential model is as following. Please use a calculator to add 1 plus 0.0118 to get the following. So this is the very first thing that it's asked you to do, is to create an exponential model. Now, part 2 of this question says estimate the world population in 2005. So if we started off in 2000 and then we want to estimate what happens in 2005, it's kind of telling us that t equals, hopefully a lot of you have realized by now that t is actually equal to 5, because the difference between 2000 and 2005 is 5. So we get that using this model, you can estimate the world population in 2005, which is t equals 5, exactly what we just said, to be when you plug in 5, right? 5 into our equation. Now, please keep in mind, I do want you to use decimals. So let's go ahead and jump right into that. Let's go to our internet. Go ahead and type in decimals. Start graphing, or sorry, actually it would be better to have the scientific calculator, because at this moment we're not graphing like we did before. So go ahead and use the scientific calculator and write down 6.09 times 1.0118, close parentheses, to the power of 5, and you get your answer, 6.457. So this is in billions. This is how many people existed in 2005, 6.45 billion. So in case they ask you to round up to the hundreds place, remember that the 5 now takes a look at the number after that, the place value after that, which is 7. So it rounds up to 6.46. So we go back to our problems, exactly what we see in terms of estimation, right? So we estimated. Now part B says estimate the year when the population was 7 billion. So this time it's asking you to solve for t. So when you're solving for t, now it would be a good case to actually plug these into the Desmos graphing calculator. So we want to know when y equals 7 billion. So what we're going to do is we're going to plug in our model, y equals 6.09 times the quantity 1.0118 to the power of t, and we're going to, right next to it, we're going to also plug in y equals 7 billion. So now let's go back to Desmos. Now I'm actually going to be using the graphing parts. Let's go ahead and do this. Y equals 6.09 times 1.0118 to the power of t. Now you see this equation right here. If you want to zoom out, it is an exponential model. That's how fast we're going to grow, right? Over time, our population is growing like that. And then we're going to insert the second equation, which is y equals 7. Oops, I wrote 87. Let me go and fix that. Y equals 7, and we actually see a intersection points, right? Remember, you can touch either one of these lines, and that point will be highlighted for you. So when we have about 7 billion people, that time frame is going to be 11.87 years. So 11.87 years, if we round that up, is about, I don't know, 12 years. Is about 12 years that it takes for the population to get to that state. Again, so this is exactly what the answer says. So use the table. So they're talking about you having a scientific calculator, like one of those handheld ones, not like the ones that we just did on Desmos, to determine that when y is about 7. So you get that t equals 12. So what they decided to do was round up, because again, this value here, whoops, let me go ahead and bring that back up. This value here is time. I don't know what 0.871 of a year is, right? So what they decided to do is just say, well, if we're talking about years, so let's go ahead and round that up. So that is exactly what they did. Let me go ahead and dismiss my updates, because I don't know, for some reason it's asking me to update like almost every freaking week. So I am not down for that. Monitoring progress. So what are you going to do for homework? So in example 2, the example 2 that we've worked with, the value of the car can be approximated by the model. So they give you a different model from what was given before, right? So you're not dealing with that model anymore. Identify the annual percentage decrease in the value of the car. So you're going to find out what R equals in percentage, right? So first of all, again, this is a decay model, so you're going to do the same thing where instead of 0.9, you're going to write that 1 minus r is equal to 0.9. Then you're going to solve for r. So go ahead and do that. The next part says identify the annual percentage decrease. Oh wait, sorry, we already did that. Whoops. Estimate when the value of the car will be 8,000. Again, so it tells you you need to solve for t when y equals 8,000. So you're going to plug that into the decimals again, where you're going to plug in this equation, and then you're going to plug in y equals 8. You're not going to plug in 8,000, because this y value is already in thousands. Okay, so you're going to plug in y equals 8. So in part 6 in monitoring progress, sorry, problem number 6, in example 3, assume that the world population actually increases by 1.5 and not what initially gave us, which is 1.18. So you're going to write an equation with these circumstances instead. So instead of there being 0.0118, now obviously you all know that if you have 1.5, you move decimal 1 2 over, you have 0.015, and you just add them up and you get your new model, right? So you're going to write a model for that situation. Then you're going to estimate the year that when the world population was 7 billion. So this is a very good way to know and how to predict exponential growth. So I'm going to stop this video right here, because I'm noticing I'm taking a little bit longer, and I'm going to add the second part right away, which is example 4, right before we get into compound interest. See ya.